This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program and right now we are going through with PySpark and that is nothing but distributed computing framework in order to process huge amount of data. And what exactly the Spark is, that is lightning fast in memory general purpose compute engine. So that is Spark. And in yesterday's session, what we have seen, like what is Spark, how to have a Spark environment, and then the different ways in order to create the RDDs. Let me write it down. Okay, so in yesterday's session, we have gone through with some theory and practical, and what we have covered in our yesterday's session. What is Spark? Okay, we have gone through with the definition, then how to set up Spark environment in Windows machine. Okay, and what I assume you have gone through with this particular topic or the presentation that I have shared, and probably Spark is there in your machine. If you face any challenge, then you can ping me. I will be guiding you in order to set up the Spark environment in your machine. Without Spark you will not be able to proceed because that is the mandatory stuff. Until unless you are not having the environment, you will not be able to type code or execute code. Okay, so Spark environment setting, this is the stuff what we have covered in our previous session. Then we have gone through with different components to write code in Spark. And what we have seen over there, like we can write the code in RDDs, then data frames, okay, Spark SQL, and it will be based upon the flavor of the data. Okay, if we are having batch data, so we are having these particular things, batch data, or what I can say batch data processing, batch processing. For batch processing, RD, data frame, and Spark SQL. Spark SQL. Okay. We are having data set as well over here. Okay, data set. Okay, that is applicable to Scala only. Yeah, data sets are available in Scala. Okay, in Python we are not having data sets. Uh, Same like data frames, we are having data sets, so they are having certain other benefits once we are working with data sets. So there is no need to go in detail with respect to data sets because these are uh, limited to Scala only. In Python or PySpark we are not having data sets. Okay, then if we are having streaming data processing, then also like we can have these RDs, data frame, and Spark SQL. Okay, and once we are having this, so we can divide it into further two parts. Spark streaming, once you are working with RDs, okay, and Spark structure streaming once you are working with Spark SQL data frames or data set. Okay, Spark structure streaming. Structure streaming. Okay, so with the help of this particular diagram, what we are able to see, once we are working with Spark, or in order to process batch data or streaming data, then we are having already data frame and a Spark SQL. We can write down the code in these particular components. Okay, and we can utilize these particular components or objects or data structures, what I can say, in order to process the data. Okay, and once we are dealing with the streaming data and we are utilizing RDDs, then that is Spark streaming. That is called D stream as well. D stream. Okay, that is called D stream as well. So RDs are there, and RDs are not having a valid structure. And once we are going to map a structure, then it will be acting as a data frame. And at that moment, like data frames and Spark SQL is utilized to process that particular data. Either it is uh, streaming data or it is batch data. Moving further, what we have seen. How to create RDDs, to create RDDs. RDDs, or what is RDD basically? What is RDD and how to create the RDD? So what we have seen, there are three different ways to create RDD. First one is once we read the data. Second, once we apply transformation on data, then it will provide another RDD. And third, read the data transformation, and once with the help sc.parallelize, with the help of parallelize parallelize function. Okay, what it will do, it will convert a particular collection to be distributed onto the different machines. If we are having a collection, list, a tuple, array, or dictionary, whatever. Okay, so if we are going to have a collection, and that particular collection will be limited to a single machine only, until unless we are not utilizing the parallelize function. Parallelize function is going to distribute that particular collection onto the cluster. Okay, then what we have seen, operations, operations in Spark, and there are two types of operations: transformation and actions. So transformation is what, like transformation, once we apply transformation, it is going to provide another RDD. And Spark is lazy in nature. If we are keep on applying transformation, nothing will happen. It is going to park that particular transformation into the DAG, and that is going to record on all the transformations whatever we are going to have on top of a particular data. Okay, and once we take the action, once we apply the action, then the actual execution will begin from the beginning, and then we will be able to get the outcome. If we need to have output in PySpark, then we need to take the action. Until unless we are not taking any action, then nothing will happen. So this is the stuff, friend, what we have seen in our previous session, and we have started with a program, that is the simple word count program. And for that we are having this particular data. Okay, say hello, how are you, welcome to big data world. Big data is big, it is going to change the world. World is having huge data. Data is a new fuel. Data processing is mandatory to in order to get the insight from data. uh, Booster analytics will provide the mechanism to process big data. Okay, so these are the certain words what we are these are certain, you can say this is the certain content what we are having in this particular uh, test notepad. Let me save this. And what we want to do, we just want to calculate the frequency of each and every word. Okay, the same stuff what we have seen in map reduce. Okay, over there we have gone through with simple word count program. We were having certain content in a particular file, and then we have gone through with the simple, you can say, map reduce program that was written in Java, and that was in order to, you can say, process a particular file, and that particular file will be having the benefit of distributed computing. So we will be able to get the outcome with low latency. So methodology is same, but you will feel like over there, in order to write a word count program, we need to write multiple lines, a lot of lines we need to write, and that was a typical thing, in order to, you can say, learn Java for programming perspective. That is the typical thing. Now we will be going to perform the same stuff with less number of lines, and it will be very easy to learn as well. So same stuff we are going to to replicate over here. Okay, and at this moment we will be expecting the same output, and it will be done with low latency. Yeah, it is not going to take much time if we compare it with Hadoop. Okay, so multiple benefits are there from the developer's perspective as well, and from processing perspective as well. This is the file. Now now word count program. So word frequency calculator. Okay, this is the program that we are going to learn in our today's session. Okay, so in our previous session, what we have seen, how to read the data. Okay, this is the file that we need to read. Word frequency calculator. This is the location of the file. Now steps which we are going to take. Steps for frequency calculator. What are the different steps that we need to take? So steps. So step number one, that is nothing but reading the data. Okay, reading the data from file. That is possible with the help of this particular command, base RDD, and sc.text file, and this is the location of this particular file. So I will be able to read the file with the help of this particular command. So sc is nothing but the Spark context, and this is the entry point to the Spark cluster. So we have gone through with entry points as well. Entry points to Spark cluster, Spark context, and Spark session. Okay, Spark session for data frame, Spark context for RDDs once we are working with RDDs. That is perfectly fine. Okay, so SC is nothing but the Spark context or entry point to the Spark cluster, and this is the location of the file, and we are going to park this particular data into this particular RDD. This will be nothing but a base RDD. You can give, say, test RDD, first RDD, whatever. So as we have started from here, so then I have mentioned it base RDD. Okay, that is perfectly fine. Now step number two, once I'm going to read the data, then the data will be visible. It will be available like this. It is not. Okay, this is the different one. This is the different one. Okay, so the file is placed over here. This is what we have updated in today's session. Like we have added certain content in order to to calculate the frequency of each and every word. We have added multiple big data. Such type of words have been added so that we will be having uh, the a good analysis on top of this particular file. Okay, so once we are going to read the data, so it will be visible like this. After reading the data, it will be visible like this. It will be, say, array of string. It will be array of string. So we will be having, once we are going to read the data, it will be visible like this. This is nothing but array of string. This is string basically. Okay, so we got the data in this particular form. Just have a look. Let me start command prompt and PySpark. Okay, so the PySpark is being started, and just have a look. Version Spark context is available as SC, and Spark session is available as Spark. It is running onto the local machine, so master is local. If like we are running it onto the yarn, Kubernetes, Mesos, so the master will be mentioned over here. Like, say, Kubernetes, the IP will be there. Say for Kubernetes K8 and the IP of the machine where the master is running. Application ID with respect to this particular application or session, what we have opened over here. Fine, so far let me copy this particular line and check what is happening over here. Okay, based already. Okay, so we have read the data from this particular file, but in Spark, what I have mentioned, until unless we are not taking any action, then nothing will happen. So it has just taken this particular command, and nothing has happened, and it is going to, you can say, in this particular sessions, like it is going to have okay. Uh, so nothing is happening until unless we are not taking any action. So I am going to take the action in order to visualize like what is there inside this particular RDD. Yeah. Okay, so collect is an action, and just have a look. It will provide me array of string. So execution has happened. Just have a look. So how are you, welcome to big data. So that this is nothing but array of string. Array of string. Okay, array of string is there. Okay, so we are having this particular string, this particular string, this particular string, this particular, these are nothing but, or in other words you can say array of lines. Array of lines. Okay, so we are having this particular data. Now what we need to do, we need to, in order to calculate the frequency of each and every word, we need to split the words. We need to split the words. Okay, if we are having a particular array, okay, and if I'm going to split this particular array into the array of words, then what I need to do, I need to split based upon space. So based upon space, I will be having once I'm going to split based upon the space, then I will be having each and every word. So in step number 2, what I'm going to do, I'm going to split this particular RDD, based RDD, and we are having a transformation that is flat map. Okay, flat map is going to do what? It is going to take this particular input, the complete, you can say, array is taken as an input. Okay, and what we are going to say, this is X, huh? Okay, this is X, and if we are having X, then what we are going to do, X dot split, huh? Okay, we are going to split X, and splitting based upon what? Splitting based upon
Ashok,
space, huh? Okay,
Ashok,
so we
hello,
are going to split it. Yes,
hello.
yes,
I'm
yes,
not
yes,
able
please.
to see your screen.
Is it with everyone?
No, no, it's
No,
visible. It's
it's
visible.
visible.
uh I think
Okay,
you
I
need
think.
to join again, huh?
Okay,
I have changed my UPS, huh?
okay. Let me.
Okay, yeah. So I need to split it based upon the space. So this is the stuff what I'm going to do in step number 2. I'm going to apply flat map transformation, and I'm going to utilize lambda function over here, huh? Lambda, and X, if I'm having X as input, and it is going to split the data based upon the space, and I'm going to park it into the, say, flatted RDD, yeah. Okay, so this is the step what I'm going to take, this is the function what I'm going to apply in order to split each and every word, and then I will be having array of word, now lambda, so lambda is coming from the Python. We are having Python. Okay, inside the Python we are having certain function. So what are the different types of functions what we are having in Python? Functions in Python. Okay, okay. So first one is what I can say, built-in function. Built-in function. So with respect to built-in functions, say what we are having, print. Okay, we are having in order to calculate the length, len function is there. In order to calculate sum, we are having some function is there. Okay, so these are nothing but built-in functions inside the Python. Okay, and like Python plus Spark, that is nothing but PySpark. So these particular functions are applicable inside the Spark as well. So this is nothing but built-in function talking about. In order to have the understanding about lambda functions, I'm going to explain like what are the different types of function that we can have, that we are having. So first one is built-in functions. It's very simple. Like if you are having something, you just need to print. Okay, print mention the content, or print mention the variable, or uh, anything what you are having, it is going to print. If you are having something in for which you want to calculate the length, then length function can be applied. If you are having something, if you want to calculate the sum of that, so sum function can be applied. These are parked into built-in function category. Okay, second one is the user defined function, user defined function, functions. Okay, so user defined function, these are defined with the help of a special keyword, def, defined with special keyword def. Okay, so these are defined with the help of def keyword, and these are nothing but say user defined functions, like say if you want to calculate the sum of a particular number, if you want to calculate the square, so say you can define the function def and say square, and you can take a parameter. Okay, and then what you will return x into 2. Okay, so it will be returning the square of that particular number. It will be going to return the square of this particular number what you are going to type. And then what you can do, you can print, uh, you can like take this particular function, say square, and call this particular function, and you can mention a number, okay, over here, and then you will be able to get the outcome up. So this is nothing but function definition, and this is nothing over here what we are able to get like function calling. Over here we are calling this particular function. Square is the function that what we have defined over here. It is going to take one argument, and it is going to return, it is going to perform the calculation that is nothing but x square of 2, x square, x square. So uh, now if we are passing this particular parameter, passing the value of this particular parameter which is declared over here, and calling the function, that it will provide me the output. So it will give me 25. Okay, so this is nothing but user defined function. If you want to have the calculation of something, or if you want to define a particular function, you can think in this particular way, like you are having certain parameters, or counters, what I can say. You are having certain counters, and you need to calculate the KPI from that particular, from those particular counters. Now you are having, you can take those particular counters as a parameter over here. Okay, then you can calculate based upon those particular parameters. Okay, and then you can return the value of that particular KPI, and then you can call the function. In the while calling the function, you can pass the values of those particular parameters, and then you will be able to have the KPI of those particular counters. So you can have your own functions with the help of def keyword. These are built-in function. You just need to type, and you will be able to take the benefit. Okay, over here you are defining the functions as per your use case. Okay, whatever you need to do, and then you will be able to take the benefit. Okay, so this is defined with the help of def keyword. Okay, so first is built-in, second one is user defined, and third category of function is anonymous function. Anonymous function. So it is denoting function without a name. Function without a name. Okay, anonymous functions are nothing but functions without a name, and this is like the benefit of, you can say, Python, where like we will be able to define the functions without the name. So over here what I can do, these particular functions, these are defined with a special keyword, lambda. Okay, so these are defined with the help of lambda. What we are using over here, lambda is nothing but function without a name. Okay, so over here what I can do, and over here like we will be having less lines of code. Once we are using lambda function, then we will be having less lines of code. It is having less lines of code. Okay, so just have a look over here. Say if you want to calculate the square. Okay, so what I can do, lambda, and I will pass say x, and I will have x, let me type in small letters, and I will have x square. Okay, x square. So it is going to provide me the square of this particular value. Okay, so square is a, you can say, it is not a function over here. Okay, it is a, you can say, variable. And what we have done, we have used the lambda function, and we have defined an anonymous function. It is going to take x uh, as an input and provide you x square as an output. So we are passing this the value of x and calling this particular, you can say, and using this particular keyword, and then we will be able to get the output as 25. So there is no need to define function over here. Over here, like the function without name, and the same stuff we are using over here. So we are using lambda. What it is going to do, it is going to take x as an input. Like I have used x keyword. You can take, say, a as an input and a dot split as an output. So depends upon you. Okay, this particular uh, word or keyword or key or letter that you are going to use, it must not be a special keyword. Like we are having special keywords in Python and PySpark. So the letter word that you are going to use over here, that must not be the special keyword. Okay, so this is nothing but anonymous function, a function without name, and we are having the benefit, like we are able to type it or to take the benefit with anonymous function with less number of lines. And it is it is very easy to understand as well. Definition, like over here, like we can like proceed with this particular stuff as well, but we need to type more lines, and we need to declare a function, we need to define a function. Okay, we need to call the function and all. Okay, those particular things are there with respect to the user defined function, but anonymous functions are not like that. Okay, so that is the anonymous function. We are having certain other types of functions are there. Fourth one is recursive function. Recursive function. Okay, so function calling itself. Recursion is what, like once we are going to iterate on a particular value, so these functions uh, used to call itself. What I can say, function calling themselves are known as recursive function. Recursive function. Okay, so with respect to the recursive function, what I can say have, mm, okay, so function calling itself. So how we will be able to implement? So recursive function calling itself. So what I can do, say the example. So say if we are going to calculate the factorial of a number. So say def and say factorial of a number. So I'm going to take n as a parameter. Okay, and if I'm having n equal, say, 0, then I'm going to have, say, return 1, return 1. Okay, else what I will do, else return n into factorial of n minus 1, n minus 1. Okay, and then what I can do, I can print the factorial. I can pass this, I can call this particular function. Okay, factorial of say 5. Okay, so what is happening over here, we have defined a particular function, and function calling function is nothing but recursive function. Over here the recursion is happening over here, like we are using recursion. So if n equal to 0, if like we have given the value of n equal to 0, then it will return 1. That is perfectly fine. But if n is not equal to 0, then what it will do, it will return n into factorial. So over here this particular function is calling function itself, right? Function calling function is recursive function, factorial of n minus 1. So if say it is not if it is say 5, then 5 into 4, n minus 1 4, then it will be 20. Okay, it is going to then what you need to do, like you need to reiterate it again and again. So you need to check. Okay, and the main thing over here, like you just need to have the understanding about the function. You can like decrease the value of n over here. Okay, and what you can do, return 1, n equal to n minus 1. Okay, what it will do, it will return 20 and n minus 1 equal to n minus 1. Now the value of n is will be decreased. Then you need to pass it with for loop or while loop. Okay, and then you will be able to calculate the factorial. The main thing is not like to calculate the factorial, but to provide you a view, like how a particular function is going to call itself. Okay, function calling, it's a function that is nothing but recursive function. Recursive function. Fine. Is it fine with everyone?
Yes, Ashok, clear.
Yes, yes, Ashok.
Okay, so give me a minute. Okay, so over here, the factorial, like the function calling function over here, what will happen, the factorial is going to have the calculation. Okay, until unless it is not 0. Okay, then like the calculation will be keep on going. Say the factorial of 1, it will be 1, the factorial of 2, it will be 2, the factorial of 3, it will be 6, the factorial of 4, it will be 24, the factorial of 5, it will be 120. Yeah, so you will be able to get the outcome. the main thing is like how the recursion is happening. Like over here, this particular function we have defined, it is going to call itself, and we will be able to get the outcome with respect to a given value. Okay, so that is nothing but recursive function. We are having some other kind of functions. Let me recall. Okay, so certain other functions are there. Say generator functions. Generator functions. These function generator functions, what I can say, generator functions. Let me try to recall.
Random generator, range, this type of function is
Someone was speaking.
sure. Random generator and range function, this type of function is part of the data function.
No, 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 no. These are utilized less, to be very frank. Okay, but what exactly is happening with generator functions? Let me tell you. These are utilized, these functions are having a special keyword called yield. Yield. These are defined with the help of yield. Okay, so this is a keyword. Yield is a keyword in Python. This is a keyword. Yield is a keyword, and it is defined within a generator function to provide a value back to the caller and pause the execution. What is the meaning of this? It is defined within, say, within generator function to provide a value back to the caller and pause the execution of the generator function. Okay, over here, like we are having inside the generator function, we are having next as well. Okay, when the generators next method is called the function resume execution. Execution right after the yield statement. Yield statement. Okay, so generator function, that is nothing but defined with the help of keyword yield. And once like we are having yield keyword, then it is going to pass a value to the caller. Okay, the caller function, and pause the execution. It will be paused until unless we are not having the next statement, next you can say method inside the generator function. And once we are having next method in the generator function, then the execution will start. Okay, so this is a little bit you can say complex uh, in order to get the understanding. Okay, we can proceed with a particular example. Say we can define a function, say the range underscore values, range values. And what we can have: start, we can have stop, and we can have step as a parameter. These are the parameters what we are having. So in Python we can ask for the values, whatever the parameter that we are going to define, we can ask for the values, or you can uh, provide a value during the function definition itself. So we are defining a function over here. It is going to accept three input. One is given over here only, and two we can define now. So the function definition is done, that is perfectly fine. Now current is a parameter, and it is a pointing to start. Current is parameter. Now we are having a while loop, and it is a current less than stop. Okay, and what I can have, yield current. Current, and current equal to current plus stop. Current equal to current plus stop, or current plus equal to stop, both are the same thing. Okay, and what I can have, I can define say for number in my range, number in my range values, and it will be say 1, 10, and say 2. Okay, and then what I can have, I can print the number. Okay, let me try to execute it with PyCharm. Mm-hmm. Now you need to tell me what will be the output of this particular function. So for num in range 1, so start is with 1, and stop what it will be? Stop will be 10, it will be 1 to 10, so 1 to 10, so it will be say
Stop will be
1.
9, na?
Yes, stop will be 9, value is given to 1 to 10, so it will be less than this particular number what we have defined over here. Now what will happen, so will you tell me what will be the output of this particular function?
It's one
1,
starting from
2,
one.
3, 4, 5, 6, 7, 8, 9.
No, sir, it's one. After that, 3. After 5, 7, 9, 10.
No, but in define itself, step equal to 1 already defined now.
So what is the meaning of this? The generator function to provide a value back to the caller and pause the execution of the generator function. Okay, so I think it is started. It is taking time. So what will be the output? 1, 2, 3, 4, 5, 6, 7. Who is saying this? And someone was saying 1, 3, 5, and 7 and 9. Okay, what will be the output?
Second one, 1, 3, 5, 7, 9.
This will be second one, sir.
Hmm. Okay, so just have a look. It is started. Let me try to create a file, say generator function, and let me type this code over here. So indentation is incorrect, so I need to correct it. Okay, let me copy and paste it over here. Now over here, this particular for function is going to handle this particular generator method next. So generator next method is handled with the help of this particular for loop. Okay, and over here, like in the function definition, it might be possible like we can pass the value, but we can overlap, we can change this particular value with this particular definition. Okay, it will be overlapped. Okay, 1 10 and then 2 will be the step, 2 will be the step over here. The current is equal to start. Okay, so start is nothing but 1 over here. So that is perfectly fine. While current less than stop, okay, is it less than stop? Stop is 10. Yes, it is step. It is, you can say less than stop. Yield, yield, that is equal to yield current. So what it will do, yield current, what it will do. So current is what over here? Current is 1. Okay, current is 1, yield current. So it will, it will stop the execution. Okay, then current is equal to current plus 1. Okay, and what we got over here, like we got 1 over here, current equal to current, current plus stop, so it will be 1 plus stop. So that will be 11. Right, that will be 11. 1 plus 11, 1 plus 10, stop is 10, right? It will be 11. So current is 11 at this moment, and like the iteration will be done, so it has stopped the execution now. But what it will, what come, we are having this particular for loop. So for loop, what it will do, it will not stop, it will start with the help of this next is handled with the help of this particular program, this particular part, with like for next part is handled with respect to this particular for loop. And for loop, so what it has done, it has stopped, and it has stopped, it has stopped this one. But like what we are having for loop, what it has done, it has printed the value from 1 to 10 with the step 2. So what will be, what we will be getting, we will be getting this particular output. However, like yield, what it has done, it has stopped, it has stopped the execution, but it was resumed with the help of this next. Okay, just have a look over here, current file, and let me
Ashok,
have the execution. Just a minute.
hello.
Yes, please.
But where we apply the next method in this program?
Next is handled by a for loop.
It's by default, or
No, we have taken care this particular next part with the help of for loop. You can define like with the help of code as well, but it has been handled with the help of this. So output is 1. I think we have printed the range values 1 to 2. My, okay, not stop, step, sorry. Okay, 13579. Okay, it has stopped, yield stopped, and passed the value to the caller, and then the execution or the next part is handled with the help of for loop. Is it fine?
Fine, Ashok.
All of you, please go through with this.
Ashok, in first step, it used first loop, while loop, right? And then for second step, it didn't went to this while loop. It went to this for loop. Is it or
Yes, that is.
o- okay? Okay.
Pankaj, is it fine? Naresh,
Yes,
Vikas?
yes, Ashok.
Yes, sir. Yes.
Okay,
Mm.
okay, perfect. So these are nothing but a generator function. We used to utilize these function very less, not so like first three types of functions: built-in function, user-defined, and anonymous functions are utilized a lot. Recursive functions are having certain latency-related challenges, so we used to avoid this. Generator function itself, like there are less number of chances we need to use these particular functions. Okay, the sixth number, what I can say, the higher order function, higher order functions. Okay, higher order functions. So we are having certain higher order functions. What I can say, like map, filter, reduce. Okay, these are higher order functions inside the Python, which are utilized for you can say certain special cases and perform you can say uh, certain computations and provide you the outcome. Let me show you. Okay, so higher order functions, what I can say, these are taking mm, function as an argument. Argument. So example of these functions are, example say map function, okay, filter function, reduce function, okay, reduce function, okay, reduce function. So these are nothing but certain, you can say, higher order functions what we are having. Okay, and how we will be able to implement these particular functions, higher order functions. So just have a look. So we have implemented the lambda functions. So inside the lambda function itself we can utilize these particular higher order functions. Just have a look. Okay, so what I can have, so we are having say these numbers, numbers are these numbers. So we are having these particular numbers. Say I'm having a particular list of numbers, and what I want to do, I just want to find out the even number, even number. Okay, so even number in this particular list, what I can do, I can so in order to check if a number is even number or not, then what I can do, I can take say lambda, I can take x as an input, and x modulus division by 2 equal 0. Okay, okay, so that will be nothing but the even number. If I'm dividing 1 by 2, the remainder will be 1. So that is not the case, huh? So first I am going to calculate, okay, like which are the numbers which are giving me the 0. Once I'm going to divide it with once I'm going to perform the modulus division, so I'm going to take x, okay, and in x I'm going to, x is this one over here, huh? I'm going to take x and x modulus division 2, if that is equal to 0, okay, say lambda. First I'm going to calculate lambda, and then what I can do, I can have say number, okay, and over here what I can do, I can filter these particular numbers. I can filter where, like I'm having this particular value. Let me explain it over here, huh? So if I'm having this one, so what it will do, it will take one, okay, and uh, what it, what I'm having number or numbers, so numbers will be this one, huh? Okay, so over here what I'm doing, lambda is going to, lambda function, this function is going to check if it is divisible, if like we are able to get 0 or not, huh? Okay, if I'm going to divide 1, so what will happen, so 1 modulus division 2, so what I will be getting, 1 modulus division 2 modulus division 2, just try to focus over here, modulus division 2, so what I'm getting, say 0, okay. In this particular way I'm going to have the division, modulus division, so lambda. Now what I'm going to do, I'm in this particular function, okay, over here I'm going to pass these particular numbers, okay. If I'm going to so numbers, higher order functions, what I can say, these functions take a function as an argument, so filter, so this particular function over here is taken as an argument, and then what I can do, I can print the even numbers, print say even numbers, even number, okay. So over here like the function is taken as an argument, and then I will be able to get the outcome, huh? Okay, let me try to execute it as well, huh? So we are having this, okay. So we are having numbers, these are the numbers what I'm having, so this particular filter is combined with the lambda function in order to provide you the outcome, and filter is nothing but the example of our higher order function, and over here function is passed as an argument, so what I can say, list is nothing but our inbuilt function, list is nothing inbuilt function. Over here filter, what we are doing, we are passing this particular function as an argument, it is going to take this particular function, and then we will be able to get the even numbers, okay. So the lambda function, lambda x colon x modulus division by 2, check for the even number, and filter is going to return the numbers which are even only, and then we are printing the even numbers. So over here we have typed this, and let me try to have the execution. So 2468, 2468, these are nothing but the even numbers. Okay, so function passed as a parameter, okay, passed as an argument, and like we are having certain special functions, say map, filter, reduce, which can be passed as an argument inside the functions in order to perform certain things. So filter is passed over here. We are checking if lambda is the if like it is even number or not, and if we are able to check the even number, then we are filtering. Simple. We are checking even number or not, and then we are filtering those particular even numbers. Okay. So, and then printing the even numbers. We have seen it over here, defining the list, then checking if it is even number, and then filtering it. And this is the syntax for filtering. So over here it is passed as a argument. Over here the filter is passed as an argument, and that is nothing but the higher order function, and we are leveraging it in order to find out the even values. Clear? Is it fine with everyone?
Yes, Ashok.
Yes, Ashok.
Higher order functions. So most of the time we will be using these particular functions of first three. Recursive, that is having latency, generator utilized less. Sometimes we used to have higher order functions, but like slowly we will be going to utilize these particular functions in order to solve our problems. And once we will be having good understanding, like it will take some time to to apply each and everything, but definitely like after some time, once we are having ample number of exercises, practices, then definitely we will be having the more insight, and we will be feeling more good in order to apply these particular functions. But definitely like first three functions will be utilized a lot, and the remaining three, recursive, generator, and higher order is also utilized, will be utilized, but recursive and high and the generator function will be utilized, will be having list usage. Okay, but as we are going through our with our learning journey, so we need to have the understanding about these particular things. So I will be sharing certain assignments onto these particular functions, and then like post going through with that particular assignment, you will be having a little bit more clarity. Okay, now coming back to the point, we have used the lambda function in order to split the values. So this lambda came from here, from the Python only, a function without name, and it is providing us certain other benefits, like we are writing the code with less number of lines, the modularity, okay, coding mechanism is fine, execution is also good over here, like it is not going to take much time. Okay, it is going to save the space as well. Okay, so so lambda functions are utilized. We are able to split our data. Okay, now in the step number 3, what I can do, say if I'm having this particular array of word, after splitting the data, so I will be having the outcome like this. This will be the output once I'm going to split this particular array of lines to array of word. Okay, I will be having this. I will be having this. So in MapReduce, what we have done, we have mapped one with each and every keyword. If you are able to recall, in order to proceed with word count program, so if we are able to map one with each and every keyword, and then like work on to the values, keeping the keys, then we will be able to get the frequency of each and every word. Are you able to recall?
Yes,
Yes,
Ashok.
yes,
Yes.
Ashok. Yes.
Okay. So in the step number 3, what I will do, I will try to map one with each and every keyword. Okay. Each and every word, I'm going to map one. Say one, how, and it will be like this. Okay. So it will be like this. So hello is there. I'm going to map one with hello, and I'm going to map one with how as well, and I'm going to map one with each and every word what I'm having. Okay, that is my expectation. That is my expectation. I'm going to map one with each and every word so that it will be easy for me to calculate the frequency of each and every word. Okay, perfect. So in order to have this particular outcome, what I will do, I will take the flatted RD, okay, and on the flatted RD, I'm having a transformation that is known as map transformation. What this particular transformation do? It is one-to-one mapping, one-to-one mapping, one-to-one mapping. Okay, so over here with respect to the flat map transformation, flat map, it can be many to many, one to many, one to many. It can be anything, many to many or one to many. Like we can have multiple lines, we can, over here we are having single line, but we can have many lines and it can provide me the many keywords. Okay, we can have one line, it can provide me multiple or many words. So flat map is working in this particular way, but map is having one-to-one mapping. If I'm providing X, okay, if I'm providing hello, it will provide me hello comma 1. If I'm providing how, it will provide me how comma 1. So how it will be executed? So flatted rd dot map and lambda, if I'm passing X, so I need to have X comma 1. Okay, so that is my expectation with respect to the map transformation, and I'm giving a name, say mapped RD. Okay, mapped RD. Okay, so just have a look. Let me copy this and paste it over here. Mhm. Flatted on double T. Okay, flatted RD. Is it flatted RD? That is fine. Flatted RD dot map lambda. Base RD, and then on base RD, what I'm going to do, I'm going to have the execution of this flatted, that is going to split. Now I'm having map RDD that will be applied onto the flatted RDD. Okay, that is perfectly fine. I think previously it was having certain challenges. Now mapped RDD dot collect. Okay, okay, just have a look. So this is what uh, mapped RDD. So this is not what we are expecting. If I'm going to have this. Okay, so hello one, how one, R1, U1, welcome one. Is it correct? This is what we were expecting. This is what we were expecting with respect to the mapped RDD, step number 3, right?
Right, Ashok.
Yes, yes,
Okay.
yes.
So one-to-one mapping is done with the help of map transformation and one-to-many, many-to-many, that is given by flat map transformation. Lambda is a function which is utilized in order to process. Okay. Fine so far. Then
Yes,
step
Ashok, yes.
number 4. Perfect. Step number 4. So with respect to the step number 4, friends, if I'm able to keep, say, if I'm having say hello that is given say 4 times or 5 times. So if I'm able to keep the key and work on values say 1 plus 1 plus 1 plus 1 plus 1, so 5. So what I will be having, hello 5, right? Hello 5, hello comma 5, and this is what, friends, what we are expecting. Okay, we want to have the frequency of each and every word. So I need to apply a transformation which will work on values and keep the key itself. Take the key and work on value. So at this moment, what I'm going to do, I'm having a particular transformation that is nothing but reduce by key. Reduce by key. And what this particular transformation will do, it is going to take x comma y and it is going to provide me x plus y. What is the meaning of this? And I am going to utilize a lambda function. Lambda. So it is going to take x comma y and provide me x plus y. Okay, so x, what is x over here and what is y over here? So inside the reduce by key transformation, it is going to take the two rows at a moment and keep the key itself, reduce by key. Okay, keep the key and work on to the values. So it will be the iterative operation. Reduce by key is going to be performed iteratively until unless all the keys are taken into consideration. And what is the meaning of this? It is going to take two rows at a moment. Okay, so with respect to, like, we are having 5 records, but only 2 will be taken for the processing. This is x over here and this is y. Okay, so hello 1 plus 1, what I have mentioned, if I'm passing x comma y, this is x, this is y, so it will provide me x plus y, so x plus y. So in the first iteration I will be getting 1 plus 1. So hello will be hello comma 2, this will be the output of first iteration. Hello comma 2. Now the second iteration will be there. Then what it will do, it will take these two records, okay, and keep the key and work onto the values. Now this is x and this is y, so 2 plus 1 after the second iteration. So hello will be 3 over here. Okay, hello will be 3. Okay, so hello will be 3 at this moment.
Ashok,
So
what if
uh-huh.
keys will be different?
Keys will be different means, so for each and every key it is working.
Okay,
Okay, it
first
is
it
going.
will separate keys, huh?
Yes, 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 yes. So what exactly is happening inside the reducer if you are able to call? Shorting and shuffling is happening, and shorting is going to short the same keys at a same location,
Okay, okay, okay.
Okay. Are you able to recall, like, once we are having uh, the movement of records from mapper to reducer, so shorting and
Yes,
shuffling is
yes.
there. Okay, so
Yeah,
the
yes.
shorting and shuffling will try to keep the same keys on a particular location. So we will be having all hello 5 like given all together, and respective, like, that will be replicated, the logic will be replicated to each and every key. So we have taken hello for the explanation perspective. So hello is 3 over here. Hello is 3. Now what it will do? It will take two keys. Okay, and sorry, it will take the hello, and x is this one and y is this one at this moment. So hello will be 4. Hello comma 4, and then what it will do, it will take these x and this y, and ultimately we will be having hello 5. So say this is first iteration. Okay, so first iteration. Okay, so hello is 2 over here. This is nothing but second iteration. Okay, this is a third iteration, and this is a fourth iteration. Logic is clear, right? Are you able to get the logic?
Yes, yes, Ashok.
Yes.
Yes.
Perfect. So we can give a name to this particular RDD, say reduced RDD, and it will be working onto the mapped RDD. Let me copy and paste it over here inside the Spark shell. Okay, so reduced RDD. So we have applied the transformation, so nothing has happened until unless we are not taking the action. RDD.collect. Okay, collect is an action. Once we are going to take, once we are going to apply the collect, so the execution will happen, and just have a look. We are able to get, say, how is 1, r is 1, u is 1, 2 is 3, big is 4, world is 3, it is 1, going 1, use 1. Okay, so previously this particular code was written, I think, into hundred of lines, and at this moment we are able to have the execution of this particular code within 4 lines. Complete code. Are you able to get? Hmm?
Yes, Ashok.
What has happened? Hmm. Okay, so this is the complete code. Now over here, if we are going to have these are nothing but transformation. On this RDD we have performed this, we have on this RDD we have performed this transformation. So this is RDD1, RDD2, RDD3, RDD4. So until unless we are not taking any action, then nothing is happening. Okay, and once we are going to take the action, then the execution will is happening from the beginning, and it is going to perform all the operations, and where these particular operations are kept in the DAG. So with the help of DAG, we will be able to get the output. Now, if a particular RD is modified, modified like if it is not immutable, if it is mutable in nature, then we will not be able to get the output, correct output. Okay, so RDDs are mutable in nature. Once defined, it can't be changed, and then we will be able to get the outcome. We are having parent and child relationship. This is the parent one, this is the child one, this is parent to this one, this RD is having child this one, and sorry, this is the child, like this is the last RD, and for this one is parent, this you can say RD. For this child RD, this one is the parent, and for this child RD, this one is the parent. So in this particular way the execution will happen. Now how to execute this particular code in IDE? Okay, over here we have done the execution onto the Spark shell. Okay, this is the shell environment, and we are typing our code line by line, but this is not the way to work with Spark. We need to utilize a particular IDE. Now if I'm going to type this particular code over here, then it will throw certain challenge errors. It will provide me certain errors. I'm copying and pasting the code. Okay, and let me mention, say, first Spark code, or PySpark code, PySpark code. Okay, so it is not able to get what is this RDD and what is based RDD. It is not able to get. Okay, is it correct? Base RDD is, this is not, we are not having base RDD. Flatted. Okay, so we need to copy this one as well. I thought I have copied this. Okay, or probably it was deleted. So base RD, let me paste it over here. Okay, now just have a look over here. Flatted, flatted will come from here. Okay, now over here it is throwing the error. It is throwing the error, and which error? Unresolved reference. So SC. So SC is nothing but Spark context. Okay, and if we are not having the Spark context, then we will not be able to have the execution of Spark code, right? In order to work with Spark, we need to have the Spark context. So what I can do, from PySpark.sql, so what we need to do, we need to uh, import the Spark context from PySpark import Spark context. What I think, Spark context, context. spark context, and spark context is there. Now I need to define sc equal to spark context dot or what I can say, I will be working onto the local. It will be say local, and I need to give the application name over here. Say first Spark program. Okay, so so I have imported Spark context, and sc equal to Spark context, it is running on local, and then with the help of this, like I will be able to define the Spark context, and if Spark context is available, if sc is available, then definitely I can proceed with the execution of Spark code. And over here, like so onto the command prompt, if I'm like typing say rdd, this reduced rdd.collect, it is going to provide me the output, but over here, like it will not provide me the output. Just have a look. So I need to print the output, I need to print the output, I need to print the output. So the execution is begun. Okay, so finished with execute 0, it means the execution has been done. Execute 0, that is denoting no error. Execute exit code 1, that is denoting the errors. So what I need to do, I need to just print this particular RD over here, and then I will be able to get the output. So I just need to print this. Collect is an action. It was performed in previous execution, but I need to print the output. Okay, and we are able to get the same stuff, what we have seen. Okay, what we have seen onto the command prompt, same output we are able to get over here, okay. So this is like how we will be able to have the execution onto PyCharm IDE. Okay, what we are able to get, like this particular Spark is we are not having the entry point, so we need to define. Over here we are having the entry point, so we just need to mention that particular entry point sc.text file, so we were able to have the execution. But over here we need to define this particular entry point, okay. And what you are able to see over here, like Spark R and 3.4, this is the Spark version. Please install PSU, that is nothing, these are the warnings, so what I want to show you, like the Spark UI is available onto port 4040, what I want to show you, say mhm. Okay, just have a look over here. So this particular application onto the command prompt is keep on executing. So the Spark UI is bound to this particular port, 4040, Big Data Factory 4040, and we are able to see these particular jobs. So what we have done, we have collect output, job ID, like we have performed the collect operation, and we will be having certain things. Okay, job, then we need to click a particular job and just have a look DAG. So what we are doing, we are reading the data from the text file, then partition by, then map partition. Partition by is nothing but flat map partition. Okay, so what we are able to get, like it is being executed. So the DAG is going to keep all of the things. DAG is nothing but directed acyclic graph onto the Spark UI we will be able to get. Once we are going to close this, okay, if we are going to exit from here, then this Spark UI will not be visible. Until unless a particular application is being executed, we will be able to have this Spark UI. Just have a look. So we will be having the application ID. Spark jobs, completed jobs, event timestamp, executor added. I want to show you something with respect to application ID. So reading the data, then show additional matrices, A1 timestamp, that is fine. Application. Okay, app start time and time. Okay, so just have a look. Local 17173078 From where it came? It came from here. 17173078637742. So whatever we are performing over here onto the Spark UI, we are having these particular values. Local, like this is the Spark application ID. Running where? Onto the PySpark shell. Okay, RDD compressed true. It is the RDDs will be in compressed state. Hive FIFO driver. So executor ID, like we are having one. We are working onto the driver. Now one node, like node executors are there. The execution is being happening onto the driver only. Host is big data factory. Okay, driver port number is this one. App start time, app end time. Serializer object streaming reset. Certain parameters are there. Resource profile. Okay, so no need to worry, but the main thing is that like we will be able to get the information about the job those are being executed onto the Spark UI. If a port is occupied, so 4040 port is occupied with the help of this particular PySpark shell. PySpark shell is having this particular port. Now we have started the application over here. We have started the execution of the application onto the PyCharm ID. For this, it is saying, say, just have a look. It is saying what? Could not bind port 4040 because on 4040 the PySpark shell is working, so attempting 4041. So with respect to this, the Spark UI is available on port 4041, but it will be available until and unless this particular application is keep on executing. Once the execution is done, the Spark UI will not be available. However, we can hold that particular state, and then we will be able to check it. So let me show you something. 4041, let me try to copy. I will start the execution, and then paste this 4141. Okay, so uh, So I think execution has been done. 4141. Okay, now we are able to get the 4041. So it is saying what? Like the Spark UI with respect to PyCharm is running onto port 4141. The execution is done, and once I'm going to refresh it, it will be gone. Just have a look. It will be gone. But over here the Spark application is keep on running. Okay, this particular application is keep on running, Spark shell is keep on running, so we are able to see Spark UI. Okay, so this is what like I want to explain, and it is up from last 1.5 hour. Okay, total uptime is this one. Scheduling mode FIFO, first in first out. Like if I'm going to type something over here, that will be executed. So scheduling mode is FIFO over here. So and what which are the different things what I have executed over here? So these are the things. Let me try to collect once again, and then we will be able to see one more application over here, one more job over here. Okay, sorry, 4040. We will be having one more application. Okay, just have a look at 1256. 1256 we have submitted another application. Okay, before this at 1238 we have submitted the application, so with respect that also taken into consideration. Let me at 1257 I'm going to submit the application once again, so we will be having job ID 5 over here. Okay, just have a look over here, job ID 5 is there. Okay, so whatever we are going to perform, it is going to be added over here, and it is going to keep on monitoring, and Spark UI can be utilized for the optimization perspective. Like how many executors we are having? So we are having 4 cores. Active node is 1, that node is 0, then total nodes we are having 1, total 1 is there. What is the total storage that is given? Okay, how many cores are there? Active task, completed task, total task, task time, garbage collection time. Okay, shuffle read, shuffle write. Driver, we are having driver only, so it is mentioned because this is like single node cluster. And once we are working with multiple drivers machines, then we will be having driver and executors over here. Okay, environment, like we have seen this storage, so you will be having the information about storage. Stages, like how many stages are there? This is like a little bit complex stuff we will be discussing on this, like what are the stages, what is the meaning of job, what is the meaning of task. Okay, so just have a look over here, we are having job, we are having multiple job over here. A job is having certain stages, and stages are having task. So job, then job is having stages, and stages having task. And let me try to click over here, and then what we are able to see, uh, jump to one, succeeded. So stage ID, this one, submitted time, duration like taken, task succeeded like 2 of 2, input, output, and shuffle. Shuffling is like movement of record, shuffle read, shuffle write. Okay, so once we will be working on to the different things. Okay, different things means like we will be having multiple executors on all, so then we will be having better clarity. Once we are having multiple files and multiple partitions, multiple tasks, so you will be having better clarity. So I just want to give you the insight, like how you will be able to monitor your jobs. So with the help of Spark UI, you will be able to monitor your jobs, and it can be it is available once you are going to start the session. Okay, it is providing like the information, say Spark UI is available onto this particular port. Over here it has shown me the information like over here the Spark UI is available. Okay, this is available over here. This is the application ID. Okay, once we are working onto the PyCharm, so the ID will be given by this name. First Spark program will be your ID. So local Spark running on local. So master is local over here, and first program is nothing but ID that you have given over here. And this is the Spark context what you have defined. Okay. So I think that's all from this particular session. In the next session, what we will do, we will have some more programs onto the RDDs, and we'll try to deep down in the world of, you can say, PySpark, and we will be having more actions transformations in order to get the understanding. And slowly, definitely we will be going to pick up the pace, and the things what we have learned in Hive, those particular things will be replicated, and I will remind you that these are the things what we have seen in Hive, and with respect to this, a little bit change there that we need to implement in PySpark or Spark, and then we will be having the processing with low latency. Okay, that's it for this particular session, friends. Interesting.
Yes, sure.
Yes, Ashok.
Yeah.
Recording is disabled. I think this session is not recorded. What we are able to see, recording is disabled for this session. I have started the recording, but I don't know like how it has been disabled. Okay, not
But
an issue.
on
Take,
my side, it is showing recording in progress.
don't know, it is disabled over here.
Still, it is showing like a recording in progress.
Okay, not an issue. I will check. Like, is it stored or not?
Okay. Yeah. Thanks, Ashok.
Do you have any query, Rohit, Gaurav, Naresh, Vikas?
Not yet, Ashok. Once I will install this
That
PySpark
is
and this.
mandatory, yeah. And like
Mm,
before coming to the next session, please ensure that you are having Spark in your machines.
sure,
Make it sure.
sure.
Okay.
Right.
Okay. Right, Gaurav, Naresh, and Vikas?
Yes, sir. Thank you, sir. Thank you.
Yes, sure.
Yes, Ashok. Sure.
Thanks, guys. Take care. Have a good day.
Thank you.